I'm Jordan.
I'm Evan, and this is CPE 233 with Professor Griffin at Cal Poly. And all quarter we've been programming on this Nexus 2 board, creating a CPU running on its FPGA. And for our final project, we had to design either a game or something that had a real-world application, and this is our project.
So what we decided to do was a topographical scanner. So what it does is the carriage moves left and right, and then the cart moves up and down, and you're able to scan a three-dimensional array that's whatever size you want, 6 by 6, 3 by 3, whatever. And what it does is all of those data points from the sensor are compiled into basically a picture that has depth in it, so it makes a three-dimensional image. If you, say, had an object in front of it and then ran it through once, flipped it over and ran it through again, you would have a complete three-dimensional image of the object. For our project, what we did was we connected our board to the VGA on the screen over there, and the board to the motors, so that when you turn this on, the image will come up there. For our project, it takes 30-40 minutes to scan an image in, and our PCB board that we had to design to control the motors between the circuit and the motors. You can't drive the motors directly off of the Nexus board. The relays are acting up, and the sensor that we got is a faulty sensor. So for our demo, we can only show that we set the input from the sensor to ones, which is something that's just so close it's always white. And then for the motor control, we can move the carriage left and down. So when I connect this to the ground, so the carriage moves down and left, and then what will happen is, if the relay was working, this would move all the way to the right. It would move the carriage down one position, move all the way back to the left, and then scan a new row in. We actually had a couple problems with this project. One was the size of the information. With the CPU that we have, we just did not have enough memory to store all of that data, so we needed to connect to the onboard RAM. The VGA that we were given was also not, it didn't have a high enough resolution for you to see anything, because it's a 30 by 40, and we're dealing with resolutions of 640 by 480. So we needed to get a VGA module that had that kind of resolution. About 2 weeks ago, we had the whole thing finished, and the VGA module needed a 100 megahertz clock instead of the 50 megahertz clock that's on the board. Although we were able to make a clock that works that fast, we needed another connection between the two boards that we didn't have. So we had to scale down quite a bit, but the signals coming out of the board are right, and so we plan on getting another sensor that will work, and swapping out the relays, and all of the signals and whatnot are correct, so we're pretty proud of it.
All right.